6 in the morning, and it's already 84 degrees in Sacramento. Not the dry 84 that burns off by noon, the thick kind. The kind where you walk outside to get the paper and come back in sweating, and the marine layer that's supposed to arrive overnight just didn't. It sat offshore. Again. You've lived through California heat before. You know what a hot week feels like. You know the drill. Close the blinds before 10 a.m., run the AC, check the forecast, wait for the weekend when the high pressure shifts and the delta breeze comes back. You've done this. Most Californians have done this a dozen times, but something about this summer feels different. Not louder, not more dramatic. Just different in a way that's hard to locate. Like the usual rules aren't quite applying, like the cooling that's supposed to arrive each evening is arriving a little less, a little later, and then sometimes not at all. That feeling is accurate, and it has a specific explanation that most forecasts don't give you. Because what's building over California right now isn't just a heat dome. It's a heat dome arriving into a landscape that has already lost 3 of the systems that made the last dozen survivable. The atmosphere above is the same engine it's always been. But what's below it? The ground, the snowpack, the fuel on the hillsides, that's not the same. And the difference between those two things is the difference between a hot week and something California hasn't experienced in its recorded history. Here's the part most forecasts skip. Picture the continent split in half, the west running warm and dry for months, the east buried in cold and snow, 2 different seasons playing out simultaneously, separated by a few hundred miles. That pattern, the one that dominated this past winter, that set warmest winter records across 7 western states, while parts of the Midwest had their snowiest stretches in years, has a name. Researchers call it the North American Winter Dipole, and what the research shows is that it used to be the backup pattern, the secondary mode, the one the atmosphere occasionally fell into. Around 1980 it started winning more often. By the time climate scientists ran the numbers across the full temperature record, it had become the primary, the pattern the atmosphere now returns to more reliably than any other. What drove the shift? Changes in the jet stream driven by decades of warming. The jet drifted northward. That drift, amplified by the mountains of the Alaskan Range, changed how the atmosphere's stationary waves organized themselves over the continent. The waveguide, the invisible channel through which atmospheric energy flows, narrowed and restructured, and the restructured waveguide now channels variability into a single preferred geometry. That geometry has a ridge over the west built into it. The dome building right now isn't an accident of this particular week's weather. It's the latest pulse of a system that has been quietly loading this outcome for 45 years. The 2020 heat wave, the 2022 heat wave, the record-shattering March 2026 event that hit 11 degree F in parts of California in a month when average highs are in the 70s. Each one felt like a separate event. Each one was a pulse of the same underlying pattern. But the atmosphere is only half of what's different this summer. The Sierra Nevada snowpack hit 18% of normal on April 1st this year, second worst on record. And before you file that under-drought concern for later, here's what that number actually means for the summer you're living in right now. The snowpack isn't primarily a reservoir. Most Californians think of it that way, a giant frozen tank that fills in winter and drains into reservoirs in spring. That part is true. But the snowpack's less visible job is regulating the summer. When snow sits on the Sierra through June and into July, it releases water slowly, a cold, steady drip into rivers and soil that keeps the Central Valley floor moist, keeps mountain forests too wet to burn easily, keeps the overnight temperatures low enough that the next day's heat has somewhere to go. It's a moderating system. The difference between a hot California summer and a California summer that runs out of buffer isn't always how hot the days get. It's whether that slow-release system is still running when the real heat arrives. This year it ran off in March, during a heat dome that hit 11-12 degrees in the desert. In March, 3 months before summer, when the atmosphere was at maximum thermodynamic disadvantage for producing that kind of heat. The snow that should have been releasing cold water into California's soil through June melted in 2 weeks, in a month, when it had never melted before. The buffer didn't gradually deplete. It collapsed. And the landscape that dome left behind. Drier soil, drier riverbeds, drier hillsides than any June in recent memory, is exactly what the dome building now is about to arrive into. So the snow is gone, the ground is dry. Hot day gets hotter. You felt this before. Except that's not what's happening, not exactly. When researchers spent 2 years inside the 2021 Pacific Northwest Heat Dome, the event that sent Portland to -160 Fahrenheit in June and killed more than 600 people, they found something that still isn't in most weather coverage. The heat dome alone didn't produce those temperatures. The ground did. Here's the mechanism. Normal soil, soil with moisture in it, uses a significant portion of incoming solar energy for evaporation. The water in the ground absorbs heat and converts it from a surface, warming force into water vapor that rises and disperses. It's the same reason sweating cools your skin. The moisture is doing work. It's intercepting energy that would otherwise raise your temperature and redirecting it into a physical process that dissipates it. When you have moist soil across a landscape, that landscape is constantly running a cooling operation beneath the surface of every hot day. Dry soil stops doing that work entirely. No moisture means no evaporation, means no interception. Every unit of solar energy that hits the ground goes directly into heating the surface. The cooling operation shuts down, and it goes further than that. The dry surface creates a feedback. Hotter ground heats the air directly above it. That heated air rises and feeds the high-pressure system sitting above it. The dome that dried the soil is now being partially sustained by the soil it dried. The ground becomes an engine running in the same direction as the atmosphere above it, instead of against it. The forecasts you read on your phone, the temperature projections, the heat advisories, are built on models that do not fully calculate the soil feedback. They are missing the physics of a landscape turning against itself. The events that have already happened are already beyond what those models said should be possible. When the March 2026 dome hit California, the models classified it as a 500-year event. It wasn't a 500-year event. It was a failure of the math to account for a dry Earth. The gap between what the models predict and what the ground actually does is widening every single year. The tools we use to warn the public are fundamentally blind to the mechanism that makes these events deadly. The dome building over California right now isn't just arriving into a landscape primed to amplify it. It's arriving into a forecast that cannot fully see it. There's a third thing. Earlier this year, a CAL FIRE vegetation coordinator went before a county board of supervisors to describe what he was seeing on the ground. He said this: rather than having moisture and cover on that material into June or maybe July, it's essentially been sitting exposed. The material he was describing is ground fuel, dry grass, dead brush. The combustible layer that sits on California's hillsides and foothills and determines how fast a fire moves and how far it goes. In a normal California year, that material stays protected. First by winter rain, then by snow sitting on top of it, then by the slow snowmelt keeping the soil beneath it moist into early summer. The protection peels back gradually through June and July until by August, the the fuel is at peak dryness and peak danger. That's the normal sequence. This year the sequence broke in March. The heat dome that collapsed the snowpack also removed the protective cover from ground fuel 2 to 3 months ahead of schedule. 2 months of additional exposure means the fuel that would normally reach dangerous dryness in August reached it in May or June. The fire season didn't start late, it started early, on fuel that had more time to dry than it's ever had. Research published earlier this year confirmed what he was observing. In years with earlier snowmelt across the west, wildfires burned significantly more acres. More time drying means drier fuel, means faster moving fire. But there's a specific feature of 2026 that makes the fuel situation worse than a simple early melt year. The wet winter that preceded the March dome grew an unusual amount of vegetation across California's foothills. More grass than normal, more brush, more material to burn. The same winter that filled the reservoirs and briefly made California drought-free also loaded the hillsides with fuel that is now, under this dome, drying out. The ground beneath California's summer is running 3 simultaneous failures. No snowmelt buffer. Amplifying soil feedback. Fuel at peak dryness. 2 months early on a landscape that grew more of it than usual. Here is what researchers found when they looked at how something as extreme as the 2021 Pacific Northwest Dome actually becomes possible. It wasn't one thing. The event required 3 layers to align simultaneously. A background atmospheric state, the restructured waveguide, the preferred western ridge, that provided the template. An upstream storm system that fed latent heat into that template and amplified the ridge far beyond what the template alone would produce. And a preconditioned landscape, soil already dry from weeks of anomalous warmth before the dome arrived, that switched from moderating the surface heat to amplifying it. None of the 3 layers alone produced Portland at 1160 F. The waveguide shift doesn't cause record heat by itself. The upstream storm needs a pre-existing ridge to amplify. The soil feedback needs a dome already running to reach non-linear intensity. It was the stacking, the convergence of a slowly shifting background state with a fast atmospheric amplification landing on a landscape that had already lost its ability to push back, that produced the event. Remove any one layer and the 2021 dome becomes a serious heat wave instead of the deadliest weather event in Pacific Northwest history. Now look at California right now. The background atmospheric state, the restructured waveguide preferring western ridges, is running. It has been running since roughly 1980, and it ran through the warmest winter on record this past year. Layer 1 is loaded. The landscape preconditioned. Snowpack at 18% of normal. Soil already in amplifying mode from March's event. Fuel exposed 2 months early on, hillsides that grew more of it than usual. Layer 3 is loaded. The only variable is Layer 2. Whether the upstream storm pattern aligns to provide the amplification that turned March into the most statistically anomalous heat event in the Southwest's recorded history. Whether the rain falling somewhere in the Pacific in the next 2 weeks builds the ridge above California into something that exceeds what this already serious event would produce on its own. That question doesn't have an answer yet. The question that doesn't have an answer yet, whether Layer 2 aligns, whether the upstream storm pattern provides the amplification that tips this into something beyond a serious heat dome, will resolve on its own, in real time, in the next 2 to 3 weeks. You'll feel the answer in your body before any forecast confirms it. But here's what's already true regardless of how Layer 2 resolves. The background state doesn't reset after this summer. The waveguide restructuring that shifted the atmosphere's default toward western ridges isn't a condition that lifts when the dome passes. It's been building since roughly 1980, and the research suggests it continues building as temperatures rise. The warm west cool east pattern that dominated this past winter broke the warmest winter record across 7 western states and provided the structural template for both the March dome and the June dome isn't going away in September. The soil doesn't fully recover in one season either. The moisture deficit that switched California's ground from moderating to amplifying requires sustained precipitation over multiple seasons to rebuild. Some of it rebuilds in a wet winter, some of the deeper deficit, the groundwater, the long cycle soil moisture, takes years. The summer that ends in October leaves a landscape that starts next spring slightly more primed for amplification than the spring before, and the fuel cycle runs on its own logic now. The vegetation that grew this wet winter and dried this summer will either burn or it won't. If it burns, next year's fuel load is reset by the fire. If it doesn't burn, it becomes next year's accumulated fuel sitting under next year's dome. Neither outcome is simple. Both outcomes feed the next summer's conditions. What this means is that the 3 failures you've been watching build through this summer aren't a single bad season that corrects itself. They're the current state of a system that has been drifting in this direction for decades and whose drift is now measurable in the record books every year. 7 western states set all-time warmest winter records this past winter. The March dome broke the all-time US March temperature record by 4°F. California's snowpack hit its 2nd worst level on record. These aren't anomalies clustering by coincidence. They're the surface expression of a restructured system producing its expected outputs. You're going to feel this dome. Everyone in California is going to feel it. The question was never whether it would be uncomfortable. The question is whether you were feeling a weather event. Bad luck, this particular week's high pressure, something that passes and resets, or whether you were feeling what it's like when a landscape runs out of its defenses at the same time the atmosphere above it reaches a new default. Now you know which one it is, and the summer after this one is going to start from here.